In this video, I'm going to show how to use Fusion360 to create a 3D model of your bracket, and then how to save it in the correct file type so that we can import it into DiscoveryLive to analyze stresses in it. In Fusion, you want to make sure that you always think about creating a two-dimensional sketch first and then create a three-dimensional model from that. So I'm going to start off in this blank document by creating a new sketch with this button up here. Like many design programs, you have to define what plane you're working on. Since we have no existing objects, it's one of the three planes around the origin. I'll just choose one. The thing I'm going to do first is try to tackle the design constraints. So I'm going to make my bracket so that it's mounted on the wall here, which had to be 30 centimeters between mounting plates, and then this being 40 centimeters outwards to support the weight at the end. So I mainly just use these tools up here, particularly the line tool. So let's make a line, first of all, that's 30 centimeters down. I clicked my starting point and released the mouse. It now wants me to tell it where the other point goes. It also has highlighted the length box to the left there, so it allows me to type in numbers. Notice in my document I've got the default unit set to millimeters, but if I type in 30 cm, it will automatically convert that to the proper units in millimeters for me. Now I can't see the line there anymore, so in Fusion, use the center scroll wheel to zoom in and out. If you click and hold that center scroll wheel and move the entire mouse, you've got the pan option. And if you want to ever see this in 3 dimensions, hold down Shift on the keyboard with your non-dominant hand, the center mouse wheel, and then move the whole mouse. So now that's a little confusing. I'm going to go back to the straight-on view that I had, rotate to the orientation I wanted. I'm going to again make a second line that goes out 40 centimeters. So once I have this going straight, I'll type in 40 cm, and that's defined. And I'm going to make a real basic kind of just triangle of a bracket here for this demonstration. Since I just used the line tool, I don't need to go back up here and click it. I can just right click and then go to the last thing I used. That's always this top option, which was the line. I'll start here and close this off. Whenever you have enclosed shapes, it'll highlight that shape so you know it's completely enclosed. The rebar itself is actually round, but an OK model here is if we have it be in a rectangle. So I'm going to keep the width the same, which is about 1 centimeter. That's the diameter of the rebar, or pretty close. I'm going to get in here real quick to see what the length of one of these big cells is. So right there is 10 millimeters, or 1 centimeter. So if I zoom out a little bit, I know 2 of these grid units is about the width of the rebar. I'll just use that as a reference because we're trying to make a good approximation, but it doesn't need to be entirely accurate. I'm going to hit Escape to get out of that line tool, go back to using that line tool. I'm going to start here. I'm going to imagine that this top length here is the rebar. Let's drag this over to the very end. Right there looks about right. And then if I start going downwards, that width seems appropriate down to this point, and then closing it back up there. I did zoom out a little bit while I was still drawing the lines, changed the size of my grids from 1 to 2. If you can see that in the video, and that's okay. I had some of those green guidelines that let me know I was right below the point that I'd started out with. Okay, so we're still working in a 2-dimensional sketch here, but let's make it 3-dimensional now. In order to do that, I need to stop sketching. You have this button up here to click. Then I'm going to use the extrude tool, a real common one. You can click on this button, or you can just press E on the keyboard with your non-dominant hand. Extrude lets us pull on a 2-dimensional face and make it 3 dimensions. So I want to take this outside shape, clicked it to select it. It gives me a text box here, how far I want to pull it out. Again, 10 millimeters or 1 centimeter is about the correct diameter of a piece of rebar. So I'm going to type in 1 centimeter, hit enter to commit that. Doesn't look like much change, but if I actually go to the 3-dimensional view, holding down shift and panning this, we can see I've made actually a 3-dimensional shape. Kind of looks like a bracket. The next step, we have to add those mounting plates to the end here. If we don't have those mounting plates when we put this into DiscoveryLive, it won't know what points we're actually trying to hold fixed in space to run our stress simulation. So that's going to require a new sketch, but it's going to be on this plane. So just like we did before, select a new sketch. and I've got a lot of faces to choose from now. I want to make sure it's this back one, so be careful about clicking on that. You can always zoom in if you're not able to see clearly what you selected on. The orientation worked out pretty well for me there. I know that I've got it still upwards. If it had pivoted on me, you could always use these rotation tools to put it back in a view that seems more logical to you. Alright, so I'm in the sketching mode in this face, and I need to make those mounting brackets, which we said were about 1 inch high, 2 inches wide. The brackets will be rectangles, so I could use this tool right there to try to guess what that would look like, but if I end up with the wrong dimensions and my triangle is off center, that's really annoying. So we have another tool up here under the sketch options for rectangles, which is one of my favorite, the center rectangle. So I'm going to use that tool instead to make sure that my mounting bracket is the proper distance on the back bar here. So right here, if I go across this line, I get that triangle. That means it's the center of this line segment. I'm going to start my rectangle there. I clicked once with my left mouse, and I start to pull this out, and we see that rectangle first wants me to tell it the height. So I'm going to say 1 inch. I'm going to hit tab on the keyboard to go to the width and enter 2 inches. Since those both look right, I'm now going to hit enter to keep that change. This right now is a wafer thin sketch plane. It doesn't actually have depth to it. So like before, I'm going to use the extrude tool after I finish sketching to pull this shape out into three-dimensional space. Since this part of the supporting bar was also already in the plane that I drew the rectangle, it treats these as separate shapes. So to include this in my extrusion, I'm going to hold down either Shift or Control on the keyboard and then click it to add it to that group of things that I want to extrude outwards. The distance is the width of the mounting brackets. We'll be using some stock steel bar that's about 1/8 of an inch thick. As a decimal, that's 0.125. And I have to put the units on there since I'm in millimeters, so it knows how to convert that. I'll hit enter because that looks good, and I've got one of the mounting plates. If you really want to be detailed, you could put the 2 holes in here that we're going to drill, but for our simulation, it's okay if we just have this triangle or rectangle defined right now for mounting. Alright, that's looking pretty good. I'm just going to quickly repeat that to make the plate on the bottom here as well. So once again, create a sketch on this back face. I'm going to use the center rectangle tool. I'm going to make sure that it finds that center point of the bottom. I'm going to pull it out and type in the numbers 1 inch, tab, 2 inches, enter. I'm going to extrude that after I finish sketching, either by hitting E on the keyboard or using the button I just pressed. I'll select both these faces, holding down Shift as I click the next, and then type in the width, which was 0.125 inches, 1/8 of an inch. I'll hit enter to commit that and zoom back out to take a look at my finished product. In order to save this in a file type that DiscoveryLive will be able to import, I need to make sure I go up to File and then Export, and I'm going to export this in a particular file type. There's a lot of choices here. The one that works well with DiscoveryLive is .sat, so don't forget to select that. You probably want to give it a descriptive name like original bracket design or something similar, and then be careful about where it's going to. So mine's going onto the desktop. That'll be easy to find. And there you go. That's all ready to go. In the next video, we'll look at importing this into DiscoveryLive so that we can do a stress analysis on it.